So the question says a motorcycle starting from rest is uniformly accelerated such that its velocity in 10 seconds is 72 kilometer per hour. It says, what is the acceleration? Who is talking there? So the acceleration is what you're looking for. You know your initial velocity will be zero, and the time given is 10 meters per second. Then the velocity, final velocity is 72 kilometer per hour, which you need to convert to, somebody is still talking, which you need to convert to meter per seconds. So to convert this to meter per seconds, that will be 72 kilometers, which is 72,000 in meters. Meters over 3,600 seconds. So if I divide this, I'm going to have two zeros cancel two zeros. Or let me change the color so that you can differentiate that. So two zero cancel two zeros, 36 here 1, 36 here 2. So I have 20 meters per second as the final velocity. So acceleration that you're looking for is v minus u over t, and that is 20 minus 0 over 10. Then this is 2 meters per second squared. So this is the first question there. Then the second one, is this clear to everyone? I want to hear your response. You're muted. Oh, you mute yourself so that you can distract yourselves, right? Hmm? Does it mean you guys cannot, learn in quietness? Is this clear to you? Okay.
You want you mute it? Sister.
All right. So just listen to the next one. Your attention is what matters in this kind of a scenario. So that's why I'm insisting that there should be silence when we're learning. So number two, it says the temperature of an object is raised by 120 degrees Celsius. The resulting,
That one was not clear.
okay, the first one wasn't clear, right?
Yes, sir.
Okay. Is that Messi or Sarah? Is that Messi or Sarah? Okay, listen carefully, please. Please let nobody, discuss aside so that we can all be on the same page. You said the motorcycle start from rest. From rest mean the velocity is zero, initial velocity. Then
Yes, sir.
it is accelerated such that its velocity in 10 seconds. This is the time given. 10 seconds, not 10 meters per second this time. It's 10 seconds. Let me remove something there. 10 seconds. Then we have the final velocity as 72 kilometer per hour. So once it's 72 kilometer per hour, we cannot use meter per seconds and kilometer per hour, or we cannot use kilometer per hour when we are given seconds. Is that clear? So we have to use meter per seconds, okay? And how do we get the meter per seconds? Please listen. Please make sure you concentrate. You are being distracted, Sarah. Now, Sarah, hello, calm down, calm down, calm down, and concentrate, okay? Sarah, I'm waiting for
Let's
you.
start again.
Sarah,
I'm
are you
still
ready
waiting for
now? Hmm?
hopefully it can I'll tell you.
Are you
Trust me.
ready now, Sarah?
Hmm. I will beat you back. I'm ready, sir. Trust me
Uh-huh.
like this.
Okay, please focus. Please focus. Because the essence of re-explaining is that so that you understand how we arrive at our answers. So 72 kilometer per hour cannot be
Okay,
used simply
beat you.
because we have seconds.
Hey,
Had it been
for your turn. You're
had
not
it been the
going.
time given is in hour, then we can use our 72 kilometer per hour. But now we have to change it to meter per second. So 72 kilometers to meters will be times 1,000, and that is 72,000.
Thousand.
Then
Thousand.
1 hour is 60 minutes, and 60 minutes will be multiplied
Yes,
by another
60 times
60
60.
to give us seconds. That is 3,600. So how did I divide this? I used two zeros to divide two zeros. Then 36 divides 72 to give me 2. Then that is
So
2 and
20.
0. That's 20. Then acceleration. This is the
20.
formula of acceleration, which is v minus u over t. Then that is 20, which is the final velocity that we got here. Then 0, which is the initial velocity, then time, which is 10 seconds. Then this gives me 20 over 10, which is 2 meters per second. That is clear, right?
Yes, sir.
Okay, this second one says the temperature of an object is raised. When the temperature is raised, that means we're talking about change in temperature. Theta 2 minus theta 1 equal to 120 degrees C. That is the change in temperature. Okay, so if theta 1 equals 0
Sure.
degrees C. Please concentrate. Then theta 2 will be 120 degrees C. And your theta 1, that is, because that is the only condition for 120 minus 0 to give us 120. Okay? Is that clear? And your theta 0, your theta 1, which is 0 degree, is the same thing as 273 Kelvin. And this one is going to be 273 plus 120. Okay, let me just
That's
write it here.
3882.
Okay, hold on. So
392.
this is 0
393.
plus
393.
273, which is 273, uh, 273 Kelvin. This is Kelvin, this is Kelvin. Now, this is going to be 120 plus 273. So what do you call this?
393.
393 Kelvin. So with this now, the temperature difference, which will now be theta 2 minus theta 1, will be 393 Kelvin minus 273 Kelvin. So what's your answer?
That's 120.
That's 120 Kelvin. So with this, we can conclude that uh, a change in temperature of 1 degree is the same as 1 Kelvin. Okay, is that clear? That is, the temperature change of 1 degree Celsius is the same for one
E.
Kelvin. 1 Kelvin. So that's
Okay.
why, because it's 120, and you know, and here we also arrived at 120. Okay, the next question.
I just like it
See,
because it's natural laptop. New laptop.
please, no noise.
I said, let's do something about that.
We don't have enough time for today, so no noise. I have to be on another class shortly. That is why I'm trying to. I did not say, okay, somebody solve this, somebody solve that. Now look at this
Go
question.
ahead,
Which
boss.
of the following statements about the motion of the simple pendulum is true? Listen carefully. Listen carefully. Somebody is talking. Taye
Yeah.
and
This
Sarah.
stupid, I
Okay.
mean,
Okay,
is
okay.
this food common?
Hey, um, let me. You
I
just
don't
call
know.
somebody. You just call somebody a fool, right, Sarah?
No, he called me a fool first. When I
Wait. Calm down. Calm down. I'm going to show both of you
said,
something at the end of this class. Hold on. Hold on. Just calm down. So, which of the statements is true? That is what this is asking us. It is a simple. Who is still talking? Sarah. Hmm?
so can you see most?
You said what?
Just me talking. He that's playing game. Mm-mm. What are you
Mm-hmm.
doing? Mm.
Okay. Okay.
You took
Hold
the phone
on.
to play game. I'll test
Hold
my
on.
case out. Tell me to tell
It's
me.
saying which of these statements about simple, motion of simple pendulum is true. The first one says it is a simple harmonic motion when the angle of
No, I never
displacement is large.
I wish I never had.
Is this first
You're not
statement
comfortable in my
true?
body. So,
Sarah, is this first statement true?
please, don't do. Sir? Mm.
Is this first statement true?
I don't know.
Uh-huh.
Sir, yes, maybe.
Is it true?
Is it true?
I'm asking
It is
you
a
if it
simple
is true.
harmonic motion when the angle of displacement is large. No, it's not true.
Why? Why is it
Yes,
not
it's
true?
true.
Why? Why is it true?
I said it's true. I said it's true.
Mm-mm. If it's true, explain why. If it's not true, tell me why. You
I should
cannot
still
just
explain
sit
why
on the
it's
fence for.
true.
Mm,
Okay, why it's true? Let me see it.
mhm.
Because it is an harmonic motion.
Listen, listen. Whether the
Simple
angle,
pendulum
li-
states that
listen,
the
listen. Oh, hold on. Are
angle
you
of
hearing
displacement
me?
is large.
Are you
Yes,
hearing
sir.
me? So whether the angle of displacement is large or small, it is always a simple harmonic motion. So that first statement is not true. Because the first statement is trying to condition it to only when the angle of displacement is large. So let's go to the second one to see whether it's true. It passes the equilibrium position with minimum speed. It says it passes the equilibrium position with minimum speed. That is not true either because when it is moving towards the center, it accelerates higher. Moses, are you hearing me?
I claimed them.
Okay. Okay. So Taye, are you
Yeah,
hearing me?
I my room
Taye,
can
are you
never
hearing me?
finish. Like I
Okay.
don't count.
Who else is there? Mercy, are you hearing me? Where is Mercy? Okay, Mercy is not there. Okay. Is Mercy there?
Yes.
Mercy, the Lord have mercy on you for not answering me. Mercy.
Sir?
Okay. So it possesses the second one says it passes through the equilibrium position with minimum speed. That is not true either because when it's moving towards the center, it's going to accelerate. Then it possesses maximum kinetic energy at the extreme ends. That cannot be true because as it's going towards the extreme end, the energy is reducing, then the energy will now become zero at the end before it starts increasing again. So the last one say it swings faster at the poles than at the equator. This is true because at the poles, at the equator is at the extreme end. but at the pole is at the equilibrium position. So it swims faster. And this will confirm the second one, which supposed to be that it passes the equilibrium position with maximum speed instead of minimum speed. Okay, so that is about the simple harmonic motion. So which one is the correct option here? Option D. Okay, let's move to the
Hmm?
next one. Okay,
Okay, wait.
So I'm
okay.
not copying the note. So go to another one.
Shut up. You
Well,
are you even listening?
don't worry, I'm going to send it
That's
over to
copying the
you,
note.
Sarah.
Yes, sir.
Okay,
Tell me no get.
I'm going to send it over
That's
to you.
yeah.
Let's look at this next one.
Just that.
Can you shut the fuck up? Don't let me
Hold
finish
on.
with my words.
Um,
See,
Sarah, read this one for me.
an electron of mass M and charge E moves in a circular path in a magnetic field of flux density. Sorry, of flux density. How long does it take to complete one orbit? Flux density B. How long does it take to complete one orbit?
Okay. So the motion of charged particles in magnetic field will be given by the formula by this formula which says m v square over r equal to q vb. So this is the formula. Where q is
Mm.
the q is the charge. Are you listening?
Yes, sir.
Where q is charge, then it becomes mv square over r equal to, instead of q you put e, which is a charge there, evb. Then you're trying to you're trying to divide both sides. You will divide both sides by v because v is on both sides. So if you cancel out v, you're going to be left with mv over r equal to eb. And it is this same b that is being represented in capital, capital letters. So I can change this to capital B. I can change this to capital B. Then this is capital B. So take note. Then we have omega as omega is going to come in to replace the v over r. So that is going to be m omega r, over r, but the r will not be there again. That will be m omega equal to e b, e b. So with this, the omega can be represented as 2 pi f. Then the whole expression will become
My face
2
is still like,
pi fm equal to eb or be, you know. So equal to either eb or you say be. Then the f is a factor of period, which is the time that they are requesting for. He said, how long does it take? That's the period. So that is the number of time for one complete oscillation. You are not listening. Okay. So F is 1 over T. So you slot in 1 over T to replace F in this. Then this becomes 2 pi M over T equal to B E. So here now, you make T the
or
subject
M
of the
over C.
formula. By making T the subject of the formula, BE comes down, T goes out. So T equal to 2 pi M over BE. So which of the options 2 pi M over BE? So which of the option?
C.
C. So this is the correct answer. So to round up, because we're going to round up now, what this is asking is an electron of mass M and charge E moves in a circular path in a magnetic field of flux density B.
Amen.
How long does it take to complete one orbit? So we're finding the period, which is a T, capital T. But how does it come in here? We have the motion, the circular movement to be mv square over r, which is the qvb, and the q is E. And we have mv square over r equals to evb. Then we divide both sides by v, then we have mv over r equals to eb. Where omega is v over r, we have m times omega equals to eb, or we say be. Then the omega itself is also 2 pi f. So we replace it, that will be 2 pi fm. Then f is 1 over period 1 over t, which is um, 2 pi m over t. Then you make t the subject of the formula and you arrive at this. Okay, hold on. Very quickly, I said I will show you something. Maybe it will change something. Hearing me? Fine. Are you hearing me?
Yes, sir.
Okay, hold on. So what we're rounding up already. I just want to show you.
I think
Okay, fine. Um, Moses.
God.
Okay, Sarah, read this passage for me. Read this passage for me.
you are familiar with the command to the ancient. Do not murder. I'm telling you that anyone who is so much as angry with a brother or sister, is guilty of murder. Okay, so some people call a brother idiot, and you just might find a dumb hold into court. Completely, yes, you're stupid as a sister, and you are on the brink of your fire. The simple moral fact is that what skill. This is how I want you to conduct yourself in this matter. If you enter your place of worship and about to make an offering, suddenly remember the God you prayed that against you. Abandon your offering, leave immediately, go to his prayer, go to this friend and make things right. Then and only then come back and work this out with God.
Okay, hold on. That is from the message version. Now, from King James Version, read the same thing.
But I say unto you that whosoever is angry with his brother without a cause, this can't mean that.
No.
Yeah. Shall be in danger of the judgment. And whosoever shall take his brother, Reka, shall be in danger of the council. But whosoever shall take thou fool, shall be in danger of no fire. Therefore, if
Hold
thou
on.
bring
Don't,
thy gift to
hey,
the
don't
altar,
continue. Don't continue. Just read this place for me. But what?
but whoever shall say thou fool, shall be in danger of no fire.
So do you know that we now need to be born again? Yes or no?
You're not born again. You are born again now. This way you refer to just when you
Wait, calm down.
this
I'm not asking whether
whoever
anybody
says
is born
thou
again.
stupid so
I said, do you
the
know that?
murderer.
Wait, do you know that we need to be born again, right?
Huh?
So we are not born again if we still behave in this manner, okay? But tell me that it is easy. Is it easy for somebody to make you angry and you will not say the person is a fool?
Sorry, sir, I can't hear you.
Is it easy for
I
somebody to
mean,
make you? Is
your
it easy? Hold
internet.
on. Can you hear me now?
So what did
Can
you
you,
say?
can you hear me now?
No, I can't hear you. No.
Are you hearing me now?
Sorry. Yes, I can hear you
Okay.
now.
Is it easy for somebody to make you angry and you will not call the person a fool?
Family. It's sleeping in the car.
Anyway, the point is that if it is not easy for people to make you angry and you will not abuse or curse them, then you must admit that it is not easy to be a Christian or a follower of Christ. So it goes beyond going to church, sitting in church 24 hours, 7 days a week, and it goes beyond carrying Bible up and down without doing what it says. And that is where we'll be rounding up for today.